Welcome back to this session of building materials and construction. I think in the last part of the class, we have studied the concept related to the burning of the bricks and all those things. In today's part of the class, we shall get to know what is meant by fine aggregates. One of the useful part of the materials, since I have explained even the concrete blocks also. Starting from the stones, building part of the materials, even the bricks used for the construction, and later on aspects for making the work much more faster in nature, we have also developed. That means the concept has been developed in such a manner that to make the much faster rate of the construction, we have a concrete blocks. Now, the main essential ingredients of the concrete blocks we were discussed regarding to the usage of the fine aggregate, coarse aggregate, as well as even the cement. Let us take on for the fine aggregate why it has been necessary. Fine aggregate has its varieties of applications not only in the building materials and construction, even in any of the treatment plants, whether it is in the case of the water treatment or maybe in the case of the wastewater treatment, or if it is to be utilized for any of the materials, even in the case of the blast furnace, some part of the sand is also utilized there. Thereby, let us get to know the concepts one by one related to the fine aggregates. What is meant by fine aggregates? Especially the particles which are passing, or the fragmented particles or the grain sizes which are passing in a ISC starting from 4.75 mm to 150 micron. They are being termed as a fine aggregate. Usually the term aggregate means the fragment portion of the rock. They are binded or holded together, and the fineness means here size will be lesser in nature. They are lesser in nature. They may also exhibit the crystalline nature itself based upon the texture and composition. Soil also different. And here, if you come across for the types of the fine aggregates which we find it out in a natural means, there are termed as either a pit sand or even in the case of the river sand or a sea sand. Naturally available aggregate means those are derived from the disintegration of the rocks through the physical phenomena by the weathering action, or even the sedimentary deposition leads to the formation of the fragments. That disintegration products is certainly used for varieties of the construction purpose. Let us get to understand the natural sand. Here mainly if you wanted to have the fine aggregate in terms of in two usages, one is either in the natural sand or manufactured sand, means which is prepared in an artificial manner. First thing it is pit sand. What does the pit sand it refers to? The pit sand is obtained by digging out the ground level surfaces where the vegetation cover has to be removed, then only you can able to get the surface clear with the sand portion. That kind of an sand is free from the salt impurities, and it should also be free from the clay contents. Finally, it is also utilized for all sorts of the commercial or maybe industrial or maybe a residential building construction purposes. Next thing, river sand. If you're going to take in the case of the river sand, you can see normally the sand which are being deposited along the banks of the river basin, we call it as a river sand. How they have been deposited? Due to the meandering of the rivers, the sedimentary deposit has taken place upon the flow of the water by weathering of the rock phenomena, that disintegrated products are being carried and deposited along the banks of the river. That kind of the sand, we call it as a river sand. Even it is also utilized for the construction purpose. But in today's perspective, if you're going to see, due to the exploitation of the natural resource which are available near to the banks of the rivers, it has been degraded, literally. Thereby, the demand is more, supply is less in nature. If you're going to take back in a previous 10 years or maybe a 1 decade, it was available, but later on it starts to decrease. It is not like a renewable. All these fragments, they are cyclic in nature, but artificial interference tends to cause the breaking of the cycle. Hence, the river sand is becoming deteriorated through the usage or an over exploitation, and in the literal sense, care has to be taken for any artificial means of manufacturing of the sand. Next part is sea sand. These are the sedimentary deposit that has been taking place near to the seashore regions or the coastal regions. That kind of the deposit contains salts which are active in nature. They tend to cause corrosion for the concrete. That kind of the substances shall not be utilized for manufacturing purpose. Hence, this sea sand is literally not utilized for the construction purpose. They can only be utilized only for the recreational purpose. Moving on to the next thing, artificially manufactured sand, we also call it as the sand which is being prepared, manufactured by crushing of the stones. Weathering phenomena is a natural part. If you wanted to crush the stones and all and make it into the grain size equivalent to that of the aggregate as per the Indian standard specifications, then we call it as a manufactured type of the sand. The stones which are obtained from the quarry site, they are being introduced into the crusher machine, and it has to be screened thoroughly after the crushing also. So sorting has to be taking place, then it has to be setting for the drying position. This kind of the sand is what we are going to call it as a manufactured sand. We also call it as M sand. There are also varieties of the procedures, not only the crushing of the stones or the quarries, because it has a huge opposition in India. It also poses a threat to the environment, hence an impact assessment has to be carried out for this. M sand in today's perspective can also be manufactured, for example in Jindal factories and all, whatever the byproducts which are obtained from the iron part or the ores and all, through the part of the blast furnace or the slag which has been induced, they are making into the formation of the fine aggregate, which also specifies related to the governmental rules and regulations. So these are the certain examples that I would like to give you for the manufactured type of the sand. I hope so you may have understood what is meant by the fine aggregates, natural and artificial. One thing to specify here in the pit sand, the particle size or the shape, they are angular in nature. Angular in nature. River sand, they are completely rounded in nature. These are the fine impurities containing the active salts, sodium content, and chloride content are also present. Therefore, this kind of the sand is much more finer when compared to that of the pit as well as the river sand. Moving on to the next part is tests that have been conducted for the fine aggregate. What are the tests that have been conducted especially for the fine aggregate? Let us get to know one by one. first sort of the test that we going to use here, it is the sieve analysis. Sieve analysis. If you observe it here carefully, the term sieve, it also refers to the openings or the net-like an appearance which have been made on a hollow type of the pan which is utilized, where the openings are made so that whatever the ingredients or the grain materials, they tend to pass over it. Some of the sizes which are bigger than the openings, they tend to retain there itself only. Hence, here the procedure is used to determine what is the finest content. Like as I have told that the finest content is also a very important, especially in the designing of the or even for the manufacturing of the concrete blocks, and even in for the concrete use it for construction purpose. Either it may be in the case of the M sand or maybe in the case of the natural sand also. Clear with it? Now, the sieve contains different shape as well as the sizes of an openings, starting from 4.75 mm, 2.36, followed by 1.18, 600 micron, 300 micron, 150, and finally the pan is being kept at the bottom. What is the reason? Whatever the 1 kg of the sand is taken by the quartering of a part, they are being taken, they are weighed, and finally they have been placed on the top of the sieves. They are arranged in an ascending order, okay, starting the 150 micron, then 300, 600, 1.18, 2.36 and 4.75 mm. Next part is whatever the sieves are being arranged, a lid has to be covered at the top and it has to be subjected for the sieving. You might have seen the similar example or the analogy I can give you. If at all, if the ragi or maybe any paddy crops that we call it as a rice, if it has been mixed together, how are you going to separate it? You go for the sieve analysis. For the wheat flour or maybe any other grain flour, if you take it, if any lumps of the materials are present, therefore you need to separate or segregate it or you need to sort it. That part we call it as a grading in the materials. That is the major purpose. Here, after subjecting for 10 minutes of the sieving, later on it has to be taken out. Each and individual pans, the sieve pans are taken out. They are being dumped into or they are being placed into the tray where all the materials which are being retained above there, they have been transferred it. Later on they have been weighed. That weight we call it as weight retained. We call it as a weight retained. It is also expressed either in terms of an grams or in terms of an kilograms. Next thing it is, if the weight of the all these sieves are being get to know, likewise it has to be repeated. Next thing it is cumulative weight retained. Out of 1 kg, how much amount of the weight has been retained? That we call it as cumulative, means adding up one next to another. We call it as a cumulative. For example, I am going to give you in a 4.75 mm sieve, 0.1 kilogram or maybe I can take it as 0.01 kilogram is being retained. The cumulative weight is 0.01 itself only. If it is in the case of 0.18 kilograms, therefore here it is 0.18 plus add it, you're going to get it as 0.19 kilogram. This is what we call it as cumulative weight which has been retained. Next, cumulative percentage retained divided by 100. Whatever the weight that you're going to take it, you divide it by 100. So therefore 0.01 divided by 100, it is equal to how much? 2 zeros will be added for that. So it will be like this. This is the cumulative percentage retained. If cumulative percentage is retained, how much is the cumulative percentage passing that we are going to get it here? Here it is 100% passing will take place, but for example what I am going to give it here, so 0.19 divided by 100 is equal to 0.0019. This is how percentage. For this you need to take 100% minus 0.0001, going to give you 99 point something. Here it is slightly varying, okay, 99.99 or something like that it is going to give you. How much it is? Here mainly what is the percentage of the cumulative weight that has been retained, that has to be taken. Along with this, if you are going to sum up all these things, we take it as a summation or sigma. Sum of all these things, the weight which has been retained, take it up, add all these things and all, maybe if you call it as a W1 or 2 etc. up till pan, how much you have taken all those things, then finally divided by 100, you are going to get what is the cumulative part, and divided by 100 gives you the fineness modulus content. This fineness modulus content, when it is being expressed here in terms of an percentage, literally this is in terms of an kg. If you wanted to take in terms of and converting in terms of a gram, it will be going to give you the different values. So that the range shall be varying from 2.2 to 3.2. This is just an indicator. Okay. This part, if it has been matching between 2.2 to 3.2, then the fineness modulus is said to be a well graded. If it has been beyond like that, less than 2.2, 2.1 or 2, more than 3.3, 3.4 or 5 if you are going to get it, no, it is not a well graded. So therefore there is a discrepancy in the fineness modulus part of the substance which is being given or taken as a sample content. This is how the sieve analysis is carried out. Next, moving on to the next part of the test, it is test on moisture content. What is meant by a moisture content? Whatever the amount of the water or any atmospheric moisture which is being present or which is retained in the sand agglomerates or the fragment of the particles which are being holded together, that we are going to call it as a moisture content. What is the step here? The wet sand is being taken, the initial weight should also be determined. Here mainly we are going to check what is the initial weight content, normally subjecting it to the next stage, we call it as an oven, heating it. After the heating, it has to be cooled. Then after cooling, then you need to take up the next weight content. Therefore, weight of an empty tray, next weight of the empty tray plus the wet part of an aggregate, you take it now W1, W2. Next, subject it for an hot air oven for a period of 24 hours. W1 is equal to weight of an empty tray. W2 is equal to weight of aggregate. Which aggregate? It is a fine aggregate. Weight of the fine aggregate. In which condition? It is in a wet condition. It is in a wet condition. Next, W3 it represents, this is a wet part, dry portion of an aggregate, that is weight of dry aggregate. Weight of the dry aggregate. Finally, if you wanted to determine what at the moisture content means, you need to subject it for 24 hours at a temperature T is equal to range of 105 to 110 degree Celsius. This is the normal temperature which we're going to keep it. Or if you wanted to increase the temperature, so therefore the retention time will be decreased here. In this particular aspect, you're going to study what is the moisture content which is retained. Okay, the moisture content which is being retained here, if you're going to analyze it, finally it depends upon the step which we need to give upon for it. Therefore, the moisture content is given as W. W is equal to W2 minus W3 divided by what is the weight of this wet weight content minus dry weight content, going to give you what is the actual weight divided by, because you need to take the fractional part, that is the ratio that you need to take it. In that particular aspect, whatever the dry aggregate that you have taken, W3 minus the initial weight multiplied by 100, going to give you the moisture content in terms of the percentage that you have to get it. Moisture content is another set of measurement or the test that is conducted upon the fine aggregate. Moving on to the next one test, which is specific gravity. Specific gravity is very much required for the design mix of the concrete also, and even it is also required for the water as well as the wastewater treatment. It has a multiple part of an application, but let us get to know how the specific gravity is determined. One of the glass apparatus utilized to determine the specific gravity is pycnometer. Pycnometer is a glass apparatus, and the extra fitting which we are going to see it here, it is a conical in shape. It has, we call it as a brim portion. What is the procedure now? It follows. First one is weigh the empty weight of the pycnometer. See why we need to take the weight and all. This kind of an analysis we are going to call it as a gravimetric analysis, where you are going to take the sample and determine the ranges. We call it as a gravimetric analysis. So therefore here you are going to take the initial weight of the pycnometer, W1, empty weight of the pycnometer, get the value, express in terms of an kg or maybe in terms of an grams. Here also the same thing, either in terms of an, it is better to express in terms of an grams or maybe in terms of an kilograms, need not to mix it. Next, second one, fill the pycnometer up to 1/3 portion with the sand. 1/3 portion, you need to fill it up with the sand content. Then again weight, we call it as W2. W2 is the empty weight, okay, plus the 1/3 of the sand, what we have obtained. The weight consists of this plus this. Next thing, fill the pycnometer. What you can do is fill the pycnometer with the water completely so that the sand has to immerse, and stir it up in order to extrude off the air bubbles. If the air bubbles are present, it leads to the erroneous calculation for the specific gravity. Therefore, It cannot be determined. Normal water bottle only we can use it to determine the specific gravity. Why we are using it, the conical shape? Because in order to extrude any of the entrapment of the air or maybe any bubbles. So that purpose, the aspirator has been utilized till it has been filled to this major level where the lid has to be closed, and on the top of it when the brim has been present, here the water is being passed to fill the remaining portion. You can also use a safety pin in order to extrude some of the air bubbles, fill it up completely. Finally, find out what is the total weight. So we call it as W3, which is W2 plus water completely. Next step, it states that discard all these things. Again, you take the empty pycnometer, discard whatever the ingredients which are present with the water. Then finally you fill the pycnometer fully with the water. If you determine it, then only the weight of, that is the W4 here, completely represents weight of the empty pycnometer with a water. Okay. So what does the specific gravity states? That it is the ratio of the density of the substance to that of the density of the standard substance or a material. In terms of a relative weight, weight of the given substance to that of the weight of the standard material, whichever the material, either maybe it is with respect to the water, because since the specific gravity you might have come across in the case of the fluid mechanics at this point of the time, therefore it will be much more helpful and easier. Let us get to know what is the formula to determine. Usually the specific gravity is either denoted as G in some of the textbook or maybe in terms of an S also. In geotechnical you have a separate terminology, either they can go for using the G or maybe another way, call it as even the specific weight of the substance. Okay, even the gamma is also utilized. For this purpose, you have the formula where we determine where G is equal to W2 minus W1 divided by, you have a minus symbol here, W2 minus W1. Why? What is the reason? If you see that empty weight of the pycnometer and you deduct it, and with the sand content you get only the sand. Here sand with respect to the water. So if you need to get the water content, so you have W3, W4 and W2 also. It is present. Therefore, in that purpose, W4 minus W1, you get the water, isn't it? W4 minus W1, and here W3 minus W2, W3 minus W2. So sand with respect to water you got. So this is the non-dimensionless quantity which is used to determine the specific gravity of any sorts of an aggregate by using the pycnometer apparatus. Usually the specific gravity is defined as ratio of the weight of the sample to that of the ratio, that is the weight of the sample to that of the equivalent volume of the standard which we have been taken. What is the purpose? Maybe in the case of the concreting, we have a special property to determine it. Too much of addition of the water or the size, if they are not properly or well graded, in that particular senses, what happens? They go for segregating. Segregation takes place. They tend to split up. They are not being held with respect together or bounded with respect together. The motor efficiency also tend to decrease if the specific gravity is not in a proper manner. These are the considerations normally given for the determination of the specific gravity. Okay. Still furthermore, I'll going to discuss with you when we have a interaction with you people. Now moving on to the next part of the testing. We have conducted test on fine aggregators, finished, and then test on moisture content and then specific gravity. There are another sort of the tests which are being performed. It is to determine the bulking content of the sand. What is meant by bulking of sand? Let us get to understand in a proper manner. Bulking of sand. Bulking of sand, it refers to the apparent increase in the volume due to the addition of water. Due to the addition of water, where volume tends to increases. Usually before the day of the construction activity or the molding, what the other people do, they usually use a water to spray on, or maybe on the surface of the sand and all. It has to get wet properly, and then therefore they are going to use it. This is what they are going to do. But it tends to seem that, oh, huge amount of the sand is present and all. No, bulking has to be only with respect to the optimal content. What happens if you're going to add on more and more amount of the water? Whatever the particles which have been held together due to the surface tension, it tends to drive away from one another. When the particles tends to drive away from one another, like if you have a small quantity of the sand, if you use large amount of the water, what happens? Everything is been splitting up, isn't it? Similar phenomena it has been going to happen. Another analogy I am going to give you. If you take a wheat flour, if you add a certain quantity of the water, it tends to absorb, and you can go for kneading it. If at all, if you go for adding much more content, therefore it becomes much more liquid in nature. Much more liquid in nature. It is equivalent to that of a batter. That kind of the things tends to happen here. That analogy is much more applicable for cementitious materials. Here, bulking of the sand, it depends upon the size of the grains in the fine aggregate. Either it may be a coarse grained or a medium grained or even the fine grained type of the materials that we are going to check across and we are going to see it. Now here, in order to determine the bulking of the sand, we need to determine what is the percentage of that. Normally, we have certain standard techniques to determine it, where we have an apparatus, especially the measuring cylinder. Measuring cylinder, a sand has to be taken, and then the water is also to be required. Now, what happens here? Take a 500 ml of a sand by weight, okay. Finally, though it can also be done either through the weight or volume, because last class I have mentioned that weight is proportional to the volumetric content. So in this particular aspect, you can see here, take 500 ml of the oven dry aggregate. This is the step 1. Oven dry aggregate. And it is taken with respect to the 500 ml. We denote it as a V1. Step 2, add 2% of water. Add 2% of water. mix it well, transfer the content into another 1000 ml of the cylinder. That can also be done. Or if you wanted to take it to whatever the extent, you can see through it. And here pouring the sand sample into the 1000 ml of the measuring cylinder. Finally, consolidate it by shaking it. You need to consolidate by shaking it. Measure in terms of an ml. So whatever the volume that you're going to get. So consolidate, because they may be loosely arranged. In order to make a properly arranged, you need to shake it up, and you're going to have some sort of an consolidation. Means things which are not being properly or randomly arranged, then it will be going to be slightly uniformly or homogeneously arranged. In this part, consolidate it and transfer, because when you have taken the 1000 ml of the measuring cylinder and you have taken out, consolidating it, now determine what is the markings which is made. So the graduation cylinder also shows the variations and the markings. Initially you have taken 500 ml and then you are transferring it to the 1000 ml. The next step, what happens here, it is when you take the consolidation, what is the increase in the volume? The increase in the volume we are going to consider it as V2. Similarly, you conduct the procedure especially in a continuous basis, so that the curve tends to exist, or the stage will be reached whenever if you go for adding it, then you take it as a V3, then V4, adding 2% extra, getting the what is the volume, again adding 2% extra, what is the volume, that you are going to do for it. Later on, what you go for checking it is, you need to make a list. So what is the percentage increase in volume to that of percentage of moisture added. Moisture added. When they have been added, roughly I am going to show you, maybe 10, 20, 30 or like this. What happens? It tends to increase. This is the saturation phase, and this is the phase of the declination. We call it as phase of decrease in volume. Likewise, there are many sorts of the graph that can also be obtained. This particular sort of the phenomena where the apparent increase in the volume of the sand and tend to decrease is what we go for designating it as a bulking of the sand. Now, how to guesstimate the bulking? Normally, in order to guesstimate the bulking, we have another set of the formula. Here only I am going to write it. Therefore, bulking of sand is equal to V2, because increase in the volume, minus V1 divided by V1. Okay, this is the normal formula which we are going to use it. Here, in some cases, what happens? V2 has been increasing, and therefore, what is the V2, when it has been increasing, you can see here, increase in the percentage with respect to certain increasing in the moisture content. Finally, if you increase the moisture content here, it start to decrease. At that stage, what you need to do? You need to add another 2% extra, so that it will become 4% after the volume decreases. At a rate of 4%, you need to add it, the water. So, therefore, you can able to see the curvature which is being declining in an exponential decreasing manner. This is the phenomena which we go for determining the bulk density, or maybe even the bulking of the sand. Bulk density, it has been completely a different phenomena. These are the standard procedure which has also been adopted that you're going to come across in the laboratory analysis. Hope so you people have understood the concept related to the fine aggregates and what are the classifications, tests on fine aggregates which have been coming across. Now there is another criteria. Even though some of the aggregates they exhibit the good properties to be used for the ingredients, especially for the construction purpose, they have some of the materials. What are those? Let us get to know one by one. We call it as a deleterious materials. Okay, let me take up here itself only. What are these deleterious materials? Especially these sorts of the materials they may adversely affect presence of harmful ingredients it may affect the workability conditions, like how you are going to find out stones and all, or maybe any magnet parts or iron contents which you are going to, for fillings that you are going to find out in the rice, or maybe in the case of the ragi where the food contamination or the adulteration they are going to do. In the similar manner, this material shall not be tend to be adulterated either by accidentally or through the intentional means. The presence of the harmful ingredients, you need to identify it. Being as an engineer, you need to go for understanding the concept, apply and identify it. Okay, here presence of the harmful substances means either the presence of the organic matter, presence of the salt content, as I have already mentioned. It will tend to decrease it, and we call it as the unsound materials, unsound particles, and even the clay content. Because if you take in the case of the organic matter, vegetable or decayed organic matter, the roots, they are being cut apart upon for the extraction or the excavation period, that may also tend to grow along with this, that you cannot be used for the construction purpose. Hence the dead and decayed organic matter tends to even cause the segregation, or what I have told, the workability, it tends to affect it. It tends to affect the workability condition. Next set, if you are going to take across, the organic matter mainly comprises of maybe the vegetable or maybe even the microorganisms, even the vertebrates as well as invertebrates, totally let us take it as an animal decayed parts. That sounds to be not good for selection. Next, salt content. Whenever the salt content is to be found out more, if you dig deeper into the ground and excavate it, these salts, they tend to corrode if it has been used along with the reinforcement concrete. Therefore, in that particular things, it is said to be deleterious in nature. During the bulking condition also, what happens? If you add the water solution, because water is a universal solvent, it dissolves it. Therefore, again, the density tends to changes. Unsound particles, they are the lumps which are being present, maybe a small boulders. Along with the small boulders, we also have the irregular clay deposits. These tends to be called it as a unsound particles. Therefore, they have an hindering mechanism for the setting time of the cement when it has been utilized. They hinder the setting time of the cement. which is a major critical concern. Clay content, obviously, they tends to go for the increase in the permeability and also causes the shrinkage. So these are the sorts of the deleterious materials which are present, and care has to be taken that the fine aggregate has to be free from these ingredients. This is what we call it as a good requirements for a fine aggregate. Good requirements means what? It has to be free from the deleterious materials. Getting the point clear for this? Okay. So this is related to the determination of all the tests, starting from sieve analysis, moisture content, specific gravity, bulking phenomena of the sand, determine what is the bulking of the sand and what are the detrimental of the deleterious material. In the next part of the class, I am going to take another concept that is related to the coarser part of the material. We call it as a coarse aggregate, how it is being graded, what are the different sorts of classification which we go for doing it, and what are the same test of the procedures. Is it being carried out there also? If yes, means in what manner? If no, means what is the literal senses? Therefore, stay tuned for the next part of the class. Remember all these sorts of the concepts, and let us get to meet in the next part of the class, having a live interaction in the upcoming part of the session of the class. Okay, thank you one and all.